Our lesson for today is to describe principal roots and tell whether they are rational or irrational. Does the symbol look familiar to you? If not, let us try to study its parts. The symbol that looks like a check mark with an elongated horizontal line stuck to the end of it is what you call the radical sign or radical symbol. The letter A is the what you call index. The quantity written inside the radical symbol beneath its horizontal roof is the what you call radicand. In this example, letter E is the radicand. Our lesson for today is to describe principal roots and tell whether they are rational or irrational. Most of the radicals that we will going to deal with will have an index of 2 and are called square roots. Example, the square root of 100, the square root of 25, and square root of 64. In fact, they are so common that if no explicit index is written in a radical expression, we assume that the index is 2. Taking the square root of a number is like doing the reverse operation of squaring a number. For example, the square root of 49. The square roots of 49 are positive 7 and negative 7. Since 7 squared is 49 and negative 7 squared is also 49. Therefore, every positive number has two square roots, the positive and negative. It just proves that there are always two sides of a story. Get all the facts before you jump into conclusions. However, we are more concerned about the principal root of a number, which is the positive square root. To classify if the principal root is rational or irrational, we must determine if the radicand is a perfect square of a number. Our lesson for today is to describe principal roots and tell whether they are rational or irrational. Integers such as 1, 4, 9, 16, 25, and 36 are called perfect squares. A perfect square is a product of a number multiplied by itself. Rational numbers such as 0.16, 4 over 100, and 4.84 are also perfect squares. Perfect squares are numbers that have rational numbers as square roots. The square roots of a perfect squares are rational numbers, while the square roots of numbers that are not perfect squares are irrational numbers. Our lesson for today is to describe principal roots and tell whether they are rational or irrational. Let us try tell whether the principal root of a number is rational or irrational. For example, the square root of 36. The radicand here is 36. And 36 is a perfect square because that is the result of 6 times 6 or 6 squared. Therefore, the square root of 36 is rational number. Another example, the square root of 11. The radicand here is 11, and 11 is a natural number, but since there is no other natural number that can be squared to result in 11, then 11 is not a perfect square. Therefore, the square root of 11 is an irrational number. Our lesson for today is to describe principal roots and tell whether they are rational or irrational.